So this whole exercise is related to alternative to practical questions. And the first topic from alternative to practical question is from time period. We did the first 7 questions, so I will do question 8 today. And at the end of the session, I will share this file so you can also solve the first 7 questions. The alternative to practical, you will improve in this paper. The more you practice, the better you get in these ATP questions. So it's totally based on the practice. The first 7 questions I have solved with another group, so I will share the recorded session of those first 7 questions. That's why I'm doing question 8. A student investigates the period of pendulum. Period means how much time the pendulum will take to move from one extreme position to another and then return back. Example, if you release a pendulum from point A, so the pendulum will move to position B and then to C and then return back. So that is known as the time, how much time it takes to move from one extreme position to another and then return back. That's known as the period of oscillation or the time period. So student investigate the period of a pendulum. Figure 1.1 and 1.2 shows the setup. Explain how to measure the center of pendulum as accurately as possible. So if you want to measure how to measure the center of the pendulum bob as accurately as possible. So how we can measure which position its center lie? There are different ways to do this. So what we can do, we can place the pendulum between the two rectangular blocks. We can place the pendulum, the bob, this is the bob of a pendulum, and we want to measure the center. So how we can work out which position is the center? So we can measure this length, like place a pendulum bob between the two rectangular boxes or rectangular blocks and measure the length. And this length divided by 2, what we'll get the center of this pendulum bob. Is it clear? This one? How to measure the center as accurately as possible?
Yeah.
Any doubt at this point?
Can you explain again?
Yeah, sure. If you want to measure the center of any object, so how it can be done? We can measure the total length, and that total length divided by 2 will get the center, position of the center.
Okay.
So same thing. Example, if I have this cube and I want to determine the center of the cube, so what I can do, I can just place this cube between the two wooden blocks and measure the length between the blocks. And then this length divided by 2, I will get the center. So yes, what we can mention, we can place the bob between two rectangular blocks and we'll measure the length and then divide by 2. Example, if the length is say 5 centimeter, the center will be 2.5. If the length is 6 centimeter, center will be 3. If length is 10 centimeter, center will be 5. In part B, student adjusts the length of a pendulum until the distance L measured from the bottom of the clamp support to the center of the pendulum bob, that is 50 centimeter. Like what he did, the student measured the length from the position where he clamped the pendulum till the center. And this length he got 50 centimeter. He places the bob, he displays the bob slightly and release. So what he did, he displaced this bob so that it vibrate, oscillate. And figure 1.2 shows one complete oscillation of a pendulum. He measured and record the time for 20 oscillations. So student did not record the time for one oscillation. Student recorded the time for 20 oscillations. Calculate and record in table 1.1 the period of a pendulum for one complete oscillation. So this T is a time
What
for
is L?
L is a length of a pendulum
Of string?
of the string till the center of the bob. So
Okay.
student that they mention here, student measured this length from the point where he clamped the pendulum till the center. This is a length L. First he took 50 centimeter, then he changed the length to 60 centimeter, then 70 centimeter and so on. So he changed the length throughout the experiment, as you can see here, 50, 60, 70, 80, 90. And he recorded small t is a time for 20 oscillation and capital T is a time for one oscillation. So if this is a time for 20 oscillations and I need time for one oscillation, so how we can work out the time for one oscillation? The total time,
Divide by 20.
yeah. So the total time divided by the number of oscillations. So the total time was 28.2 divided by the number of oscillations, which was 20. Some question they did record the time for 15 oscillation. If you want to find the time period, in that case we will divide by 15. If you want to record the time period for from 10 oscillation, then we'll divide by 10. So the total time divided by the number of oscillations, we get the period. So 28.2 divided by 20, what's the answer here?
1.4.
1.4 what?
1.41.
1.41. Keep one thing in mind, because as you can see here in this column, we have two decimal places. So all the numbers should be two decimal places. What if it was, for example, if it was only 1.4? So then we'll write 1.40, because the column should have equal number of the significant figure or the decimal places. Then we need t square. What does t square means? We just have to square. So the value of the t is 1.41. We just have to square. What is the answer for 1.41 square?
1.98.
So we'll write 1.92. Is it clear? B1 and 2?
98.
98?
Yes, clear.
Okay. Then this two, he repeats the procedure for a length 60, 70, 80, and 90, as you can see. And then we have to plot a graph between the t square on y-axis and L on x-axis. So I will just rewrite the values. 1.9 t square is there, 1.98. Okay. So I'll rewrite the values here, because the next page we have the graph, the length and time square. So this was 1.98. This was 60, 2.43. Then we have 70, 2.82. Then 80, 3.2, 90, 3.65. These are the values. So we need t square on y-axis and L on x-axis, and start the axis as convenient value. Convenient value means like we don't have, because as you can see here, length is not starting from 0. So we can start with any number other than 0. So we have L we need on x-axis. So what we can do, example, it is important that you label the axis correctly. So if I take this as 40, this will be 50, 60, 70, 80, 90. And label the axis. This is the length and the unit of the length is centimeter. So we write cm. For time square, because on y-axis we need time square. Our minimum, as they did not mention, start the axis from origin. So you can start with any number. Our minimum value is 1.98 and the maximum value is 3.65. So if I start like example, 1.9, we can start with any number. If this was 1.9, then 2.1, it won't fit. And or if I start example with, because how many digits are there, we need the maximum value is 3.6. So we have to reach 3.6. So this was say 1.8. This is 2.0, 2.2, 2.4, 2.6, 2.8, 3.0, 3.2, 3.4, 3.6, and 4.0. So, and it's important that you label the axis. So this will be t square and the unit is s square. Is it clear? The labeling of the axis? Any doubt till this point?
The top one should be 3.8.
Yeah, 3.8. 3.8, right. So each, after every 5 boxes, it's 0.2 or 10 boxes equals to 0.4. So each box is representing 0.04. Why we did not start from the origin, as they already mentioned that you can start the axis with any convenient value. But some question they restrict that they say start from origin. In that case, we have to start from 0. Otherwise, we can start with any value. Then we have to plot a graph, mark the positions 50 and 1.98. So this will be 1.84. This will be, because 10 boxes equals to 0.4. So each box is 0.04. So this will be 1.84, 1.88, 1.92, 1.9. This will be 1.84, 1.88, 1.92, 1.96. So it will be in between 1.98. This will be 1.98. That's the first value. Then 60 and 2.43. So this is 2.4, 2.44. So this will be about somewhat here. Then 70 and 2.82, 70 and 2.82. This is 2.8. One box, it will be 2.84. So it will be in between 80 and 3.2. So 80 and 3.2. 90 and 3.65. So 90 and 3.6. This will be 3.6 and then 3.64 and this will be 3.65. Somewhat here. Then these point, how you know that usually in the physics, you will get the straight line graph rather than curve. Most of the graphs are straight line graphs. Compared to that in chemistry, you used to have curves, but here is straight line graph. So we will draw a best fit straight line. What does best fit straight line means? Like number of the points above and below should be same. As you can see here, like 2 points are below, 2 points are above. So this shows a best fit straight line or a line of best fit. Is
You
it
mentioned the question, you have to draw a straight line or a curve.
they don't mention usually, but how you know, identify, for example, the next part, they ask determine the gradient. So when they ask determine the gradient, so you will be sure that it should be a straight line. In physics, they don't mention draw
Yes.
best fit straight line. You can identify by reading the next part of the question, but most of the time, like 90% of the graphs are straight line graphs. Is it clear till this point?
Yes.
Yes, Hamid, is it clear? Any doubt?
Not
Yes.
that clear.
Okay. Next is finding the gradient. Finding the gradient, they say it's a triangle method. So what you do, you don't have to take the same points which you use for plotting. You have to take two different points. And the distance between the 2 points which you are taking should be 5 centimeter or more. So example, I took these 2 points. So first point, we draw the line. You have to show these lines on the graph. The first line which you draw on x-axis from the point, that is called x1. So this point will be x1, and what is x1? 51, 52, 3, 4, 5. So x1 is 55. What about x2? The second point on x-axis, that's x2. So this is 80, 81, 2, 3, 4. So 84. X2 is
We
84.
can use 90 for x2.
What?
We can use the value 90.
The best thing whenever you're plotting a graph, don't take the values which you use for plotting a graph. Like take two different points on the line rather than take
Okay.
the same points which you use. You can use, it's not wrong, but try to use two different points. If that point
Okay.
lie on the line, you can take that point as well. The second point, like the first point on y-axis,
y1.
will be y1. In this case, it is 2 point. So y1 is 2.2. And the second line which you draw on y-axis, that is y2,
3.4.
which is 3.4. Now, what's the formula for the gradient? If when we find the gradient, it is
y2 minus y1 over x2 minus.
over x2 minus x1. So y2, which is 3.4, minus y1, which is 2.2, x2, which is 84, minus x1, which is 55. What's the answer for the gradient?
Uh,
What's the final answer for the gradient? 3.4 minus 2.2, that is 1.2 divided by 84 minus 55.
0.041.
So we get 0.041. What about the unit of the gradient? Unit of the gradient is the unit of the y-axis divided by unit of x-axis. So unit of y-axis is second square and unit of x-axis is centimeter. So it is second square per centimeter. The unit of the gradient is always the unit
Not
of the...
t square by length.
No, t square by length is the quantity, but the unit is s square. The quantity is t square and its unit is s square. The quantity is length and the unit is a centimeter. If we write the unit, so unit of the
Yeah.
gradient is always what is there on y-axis divided by quantity on x-axis. So we will find the gradient here. Explain why timing a 20 oscillation give more accurate than for one oscillation. So what is the advantage? Because look, for one oscillation, it will be very short and we will have a greater uncertainty as we are recording a very short interval. So the best thing is, and it also minimizes the reaction time. It also minimizes the reaction time as well. So we'll mention it reduce the uncertainty and minimize the reaction time. This is always the case, like recording a time for more oscillations rather than a single oscillation. So this was question 8 from the topic time period.